All right, guys, I don't know what's really happening here. I'm trying to set this audio setting. Can you guys confirm with me as soon as you hear me? Because now.
Yes, we can hear you, say no.
Okay, I understand. Can you guys hear me? Okay, can you guys hear me now?
Yes, we can hear you.
Okay. Now I'm not too sure. Can anyone try to unmute themselves and say something so I can see if I can also hear you guys? Just before you can ask for questions, and I want to make sure I can also hear you when you're busy asking the question.
Hello, 1 2 1 2.
Are you guys able to unmute yourself and just test that your sound is also fine? I don't know what's happening with team today. All right, guys. Okay, I will start in the meantime. Hopefully, you guys will be able. Anyone will be able to unmute themselves. Okay, because I cannot hear you guys, so I'm not too sure what may be the problem. But let me just make sure. Okay, the meeting is being recorded as well. So, last week we started with AI. Right. Last week we started with AI. Anybody remember about anything? What are the 4 elements of AI? What are the 4 elements of AI? Can anyone?
Data and algorithm, sir.
Data, algorithm. What else?
Computing power and application scenario.
Okay, perfect. All right, so remember now we spoke about the 4 elements of AI. So basically, you need the 4 elements to be able to consider that you now have an AI tool. So we will need to have the right computing power, which means the right hardware, and then we will need to have the right algorithm. And then based on the scenario, which is the idea that we have, we can be able to create an AI tool by using certain data. So guys, if I can ask, according to you, what do we do with the data? Every data that we collect, what do we do with it? When it comes to AI, what do we do with the data?
You clean it, then you use it to train the model.
Okay, perfect. So the data will be used to train the model, and can also be used to use the model. So an example can be your facial recognition system will need to learn from pictures to learn how to determine something. So if we're trying to create an AI that will determine between cats and dogs. We will need to provide, when we training the machine during machine learning phase, we will need to provide data to the machine. So we'll need to provide, let's say we provide 10,000 pictures of dogs and 10,000 pictures of cats, different pictures, dogs in different places and everything like that. So now the AI is going to learn different features of dogs and different features of cats. So from that, now the AI is going to be able to determine between cat and dogs. All right, guys. So that is how our AI tool is actually going to work. So I'm going to, so today we're starting with machine learning. Last week we spoke about different, we introduced artificial intelligence, and we told you how we can, how we call this, how we have those different type of studies that has helped us come up with all these algorithms. So we spoke about the three schools of AI. I don't know if anyone will remember the three schools that gave birth to all these algorithms. Anyone remember the three schools? Is there anyone that remember the three schools? Anyone? Anyone remember the three schools? Anyone remember the three schools of AI?
Connectionism,
Yes.
behaviorism. I forgot the last one.
Yeah, so we have connectionism, behaviorism, and symbolism. Okay, so now machine learning is the part of AI, the algorithm part. So it's the part of AI that is going to help us use the code to train the AI in order for the AI to be able to perform whatever scenario we have. Okay, so machine learning is just a core research field of AI. Remember, we need the four elements to create AI, but machine learning is part of the algorithm part of the algorithm element. Okay, so when you think of when we define machine learning, all we can say is machine learning will just be the study of learning algorithms. So we study all the algorithms that will be used for the machine to learn. So we understand that in machine learning, the way we will say, what we will say about a computer is that a computer program is said to learn from experience with respect to some task T and the performance P, and its performance task T as measured by P improve with experience. What does this mean? This means that just like human, we learn from experience in life, right? And based on our experience, we can be able to perform certain tasks. So that's what the machine also does. So the machine will learn from experience. What does it mean? It will learn from the data that we're going to provide to the machine. What is the machine learning about? It's learning about a certain task T, right? That we call T. And now we're going to measure the performance of the machine by measuring the value of P based on the task T. Okay. And then we're going to improve the experience of the machine. So we provide data to the machine. So now the machine has experience with those type of data. Based on the learning algorithm, we tell the machine exactly what we're looking for. And now we're going to measure the basic understanding of the machine of this task. So we're going to measure. So let's say we are trying to let our AI is trying to perform a certain task. So we train the AI based on the algorithm, and then the performance. We realize that the performance can be measured maybe at only 70%. But the type of AI that the scenario that we're looking for, we need at least 90%. Then we're going to work based on this and ask ourselves why we're not getting the exact accuracy that we want. So now we're going to go back to the data, to the experience, and make sure it has more experience with the data. Just like human being, once you can't do something properly, what do? You go back and learn again. That's exactly what the machine will do. All right. So as human being, when you're looking for a job, they will tell you we need this amount of time, we need your experience. So this is how machine also work. So human, we need experience, and experience is based on what we encounter in life. It's based on what we do on a daily basis. So the more we are exposed to certain things, the more experience we have in that area. The same thing, we're going to provide experience to the machine by providing data. So these data that we've learned when we learned about when you learn about big data, you learn about different data, how you collect the data, and how you're going to manage the data. So the data provided by the big data will be used to train the machine. So this data, historical data, are going to be used to train the machine. Just like human, we take our experience, and then when we have new problems that are happening, so based on the experience that we have, we can be able to react in a certain way. So with historical data, we will train the machine. Now, when we train the machine, we create what we call a model. So a model is the part of the AI that does the job. So when we say we collect a model, so let's say, for example, you are trying to create a certain AI. When you create the AI, the software part of the AI is called the model. So if you have, for example, a robot that needs to do certain tasks, so the software installed in the robot is the model, the AI model that was created. Okay, so now that we have the model, now we can put new data, and because the AI has gone through this data, it has learned from the data, the AI will be able to give us future attributes. It's going to be able to give us prediction. The AI can be able to perform the task. All right. Okay, any question on this before we can move forward? Any question? Anything, guys? Any question? Okay, no questions. Okay, no problem. All right, so and then we move to and then we have differences between machine learning algorithm and traditional rule-based algorithm. So the traditional rule-based algorithm is what we have on a daily basis on any type of software, which is not an AI. So when you look on any type of software, whatever you want to do, you create certain conditions. If you have a true, and then you run certain code. If you have a false, you run other code. This is how the software is built. So the software is built in an explicit way. So explicit programming is used to solve problem in a rule-based algorithm. And then we have rules that can manually be specified. For example, you are a university, you say condition is, you have marks. The condition is if the mark is greater than 75, and then you go into yes, it's going to be yes. If it's greater than 75, then you run a certain code that will maybe say to the student, congratulations, you got a distinction. If the answer is no, false, and then you're going to say no distinction. You understand? So this is how we can determine the rules. So the rules can manually be specified in a traditional based algorithm. But in machine learning, so in machine learning, the software that has been created with machine learning, we do not specify the condition. This condition will be chosen by the machine itself. So we use samples to train the data. So we train the machine learning. We have now the model that we want. Now, when we have new data, based on the model that was created based on historical data, the machine can be able to give us a prediction. So if I have to give you the same example here, in traditional rule-based learning, I'm going to tell the machine if the marks of a student, whenever we type the mark of the student, if the marks of the student is greater than 75, okay, let's go to 50 to pass, okay? If the marks of the student is greater than 50, yes, the student pass. If it's less, the student fail, right? But if I have to do the same scenario using machine learning, what I'm going to do is I'm going to provide historical data. So I'm going to provide maybe marks of student. Maybe I take student one, student one, student two, student three, and student four. So I provide this data with students 1, 2, 3, 4. The marks was 31, 50, 70, and then 80. And then what's the outcome? Fail, pass, pass, pass. This is the data I'm going to provide. And now the machine will learn from this and see that, okay, the outcome of this one who got 31% was a fail. The one who got 50 was a pass. The one who got 70 was a pass. The one who got 80 was a pass. So now if I give 10,000, 5,000 marks here, the machine will be able to create a certain pattern and determine what the model. It's like it's creating a formula which is going to be used whenever there's the new input. So now the machine will create its own passing mark. And now when there's a new data, you bring a new student who has 43%, the machine is going to take this value, put it in the model, which is the formula which was created based on the data, and the machine will be able to predict and say if the student is fail or pass. So that's the difference between traditional rule-based algorithm and machine learning. Machine learning, all the algorithm, the samples are used for training. The decision-making rules are complex and difficult to describe because they will be based on how the algorithm will learn from the data. So it's very difficult to describe. And then the rules are automatically learned by the machine. But in a traditional, we create the rules. Okay. Right. So application scenarios of machine learning, you can have it in your, let's say, voice recognition systems. The machine, when you think of voice recognition system, how do you create a machine that can be able to detect the voice of a person to turn on the light? All right. So, okay. So, if the light is off, right? If the light is off, and then you want the light on, right? So now you have to use your voice to give that command. We're just gonna have 3 people in the class to tell us what will be your voice command. Anyone? Anyone? If your light is off, but you want the light on, and you have a system that can actually listen to your voice and turn on the light. So what will be your command? What will you tell the machine? Let me see. Why the leeway? Why the leeway? What will you tell the machine? The leeway. Am I saying it right?
Please repeat that, sir.
Yeah, I'm saying if the light is off in your house and then you can give a command to the light to go on, what will you say?
Let there be light.
Let there be light. Perfect. Anybody else? Anybody else? Non fundo hope. What will you say?
You first need to alert the machine that you're talking to it, right? Like how they normally do it, like, hey Siri, please do
Yeah.
this. Yeah.
And then what will you say?
Please turn on the lights or lights on.
Okay. All right. So let's look at these two examples. So the first person say, let there be light. The second one say, please turn on the light or turn the light on. Can you see there's two different commands? Now, if you have to create this using traditional rule based, that means you have to create a software where you say, if if the voice says, let there be light, if the voice say, turn on the light. Now, different people will give different command. Now, your machine is not going to understand it because now you have a complex problem. The rules are complex and they cannot be described easily. So in a voice recognition now, we cannot solve this by just creating the software and telling the software if someone says. So when they create Siri, they cannot say to Siri, if someone say turn on the light, then the light must go on. Because you say turn on the light, but someone else will come and say, let there be light. Someone else will come and say, switch on the light instead of saying turn on the light. So because the rules are complex, we're going to use machine learning. So we will let the AI learn from different data. So if we have 10,000 people talking about turning on the light in different ways, the AI can learn from that and understand that command. All right. So you have it in other areas, such as in when we're talking about data distribution, when we want to understand what's happening in the shop, in what season do people buy certain things. We want to understand when do people buy certain things based on the weather or based on the season and all those things. So when the rules are complex, we use machine learning to create software. Okay, and the advantage of machine learning is we can it involve large amount of data. So this large amount of data can be dealt with machine learning. So as we understand here, when we're talking about rule-based traditional rule-based algorithm or traditional algorithm, the problems are very simple, right? We have machine learning algorithm where we will have more of the large problems and everything. So for you to just understand what it means that what we're going to do is we're going to train the data. So the machine will take the data, use mathematical formulas to input the data. And then from this data, we introduce a learning algorithm based on the scenario that we're dealing with. And this learning algorithm will now give us an actual hypothesis function, which is our model function. But now here, our model function is function G, right? But we create a target function, what we want to achieve, which is a function f. So now to measure it, so the target function f is unknown. The learning algorithm cannot obtain the perfect function. So we cannot obtain this perfectly. So we will never have 100% AI prediction. AI will always reach a certain percentage. So now we're going to take the hypothesis function here, which is just an approximate function of f. So it's very close to f. So what does this all mean? It means that if you dealing with data here, a facial recognition system to detect between cat and dogs will learn from the data. It learned from the data. It creates an algorithm that can predict animals and predict that these animals are, it's either a dog or a cat. Now, if you provide 10,000 pictures of dogs after you've created your AI, you provide 10,000 pictures of dogs to test your AI. Some of these pictures, or 100,000, some of these pictures may be classified as cats. Maybe you have some dogs that are just puppies and they look more like cats. Your system will identify them as cats. So it's not going to be 100%. So maybe your system is going to perform at 90%. That's why we say the hypothesis function will never reach 100% of the target function. All right. So now, before we know which algorithm we use, we need to first ask ourselves, what problems are we solving? What problem are we solving? Then we will see. So the type of problem you are solving will determine the type of algorithm you're going to use. There is many algorithms, but there's not a lot of problem that we're solving. So each problem that we're solving, the scenario can be different, but those scenarios are solving one problem. They're solving just a few problems that can be classified. So when we look at that now, the main problem solved with machine learning will depend on the task that we want to achieve. So we have the first problem is the classification problem. The second problem is a regression problem. And the third one is a clustering problem. So these are the three problems solved by AI. Now, looking at these problems now, if we're dealing with a classification problem, we will know which algorithm are used for classification. If we're dealing with a regression problem, we will know which algorithm are used. If we're dealing with clustering, we will know which problems are used. Okay. So before we take some example. So we have, for example, classification. So in classification, so the computer will need to specify which category, so which K category some inputs belong to. So to accomplish this task, the learning algorithm usually outputs a certain function which will have many categories. Okay, so what does this mean? It means this. It means if I have pictures of numbers, right? If I have pictures of numbers and I want my AI to identify which number it is, how many categories do you think I will need? Anyone? How many categories do I need for my AI to detect which number it is? Anyone? Anyone?
What was the question, say? Didn't properly hear it.
Okay, so I am saying this. If I am trying to detect numbers, how many categories do I have? If I'm trying to detect which digit, if the machine has to identify a digit and say this is a certain digit, how many categories the machine will need to have? Anybody can give us any random number? What you think? Anything?
2.
2. Okay. So now, how many digits do we have? I have a 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Can anybody give me another number which is not here? Is it possible to have another number which is not here? Guys, let us have an interactive class. Is it possible? Is it possible to have any other number which is not here?
No, it's not possible.
Yeah. That means we only have 10 categories from 0 to 9. So these are the categories. So if I am trying, my scenario is to detect numbers or to detect this. So the only categories I will have is only these 10 categories. So this classification problem, the classification problem means that the problem that we're trying to solve is a problem where we have a categories of answers. It can be 10 categories, it can be one. It's like if you have a problem to determine between male and female, you have two categories there. You have kind of classes. If you want to categorize between animal, that is still a classification problem you're trying to solve. So a classification problem, think of it of a class. Think of a class. A classification problem is when your scenario involves, the output of your scenario has to be a class. It has to be a certain category. So now the algorithm that's learned, the output of that will be a function, which is the category. So in this example here, if I'm trying to determine between digits, it's going to be either 0, 1, or 2, or whatever. So what does it mean? It means if I have my recognition system, my system can identify a picture with a number in it, and that number look like this. The machine needs to be able to determine if this is category 7 or category 1. How will the machine know that? I will need to provide data. So we will need to provide, let's say we will work when we do practice, we're gonna practice on an example, on this example, an example where we will have 60,000 pictures of this digit written by different people, because people can write different numbers. So we have all those data. Now the machine can be able to read people's handwriting and be able to determine different categories on that. You understand? So that's how the machine can learn from those categories. Another example can be in image classification algorithm. We create this algorithm to try and handle classification tasks. So do you understand what is classification? So this is the first problem we're solving. The second problem we're going to solve is the regression problem. So the regression problem is when the output can be any value. You understand? When the output can be any value. So the computer program predicts the output of a given input. The learning algorithm typically outputs a function Rn, which can be anything. So the example can be to predict the claim amount of an insured person or predict the security price. So an example of this can be if I tell you we want to take we create an AI which will look at data in a certain area. We are in Sandton. We are in Sandton. You are given data of 100 houses in Sandton. House number 1, this will be the size of the house, and then the price of the house, 7 million. House number 2, that's the size, and then you have 17 million. House number 3, you have the size, you have maybe 22 million. As you can see here, this AI learned to predict the price of the house based on the size. So can you see that the output of this AI can be any number? It's a continuous number. It's a continuous output. It can be any number. It's not, we cannot classify it. We cannot predict what can be the answer, what can be the category. So there's no category here. There is any value. So when we're trying to predict something like that, that's when we say we are solving a regression problem. All right. Now, the third problem we're going to solve is exactly what your Netflix, what your YouTube is solving, is a clustering problem. So a clustering problem, what we do, it's clustering problem look like a classification problem, but we don't really classify in a specific category, but we will distribute the data in certain classes. So a clustering problem, so we have a large amount of data from an unlabeled data, which is divided into multiple categories. Okay, so this will be based on the similarities of data, and then we can be able to predict. So this is used more when you have, for example, your Netflix, because you watch a certain movie, they classify that movie. A certain movie is not really similar to another movie, but there's a lot of similarities. Because there's a lot of similarities, they will put all the movie under action movies. So action movies will be certain movies with certain specification, and then you have maybe romantic movies and things like that. So you have those big classes of many data there. This is a clustering problem. Okay, so classification and regression are the two main types of prediction. Because remember, the clustering is more of a classification, but it just gives you a big class with data that are similar. Okay, so now before we can call it a day, I would like to ask. I'll give you a few scenarios, and then you can tell me what problem am I solving, right? Just for us to understand this part. Okay, you are given, this is my scenario, you are given data of previous soccer games, right? Between two teams, right? Real Madrid and Barcelona. They give you the last 100 games that they've played against each other. They tell you game number 1, the score was win. Okay, so you're trying to see you're trying to look at the outcome of Real Madrid compared to Barcelona. So the first game was a win, second game was a draw, third one was a win, you know. So you have about 100 data there. So now you're trying to create this AI to try to see the outcome of the next game. So can anybody tell me what problem am I solving?
Classification.
Yes, why do you think it's classification problem? What do you think is a classification problem?
Because there are already results, there is the matter of organizing and determining which one is which one.
Yeah, because we are choosing between a certain class. So we have, how many classes do we have here? How many categories? How many categories can be the outcome of a game?
2, 3.
3, yes. It can be a win, a draw, or a loss. So can you see that's a category? But in the same scenario, if we giving you the score, the numbers of goals that were scored, the first game they scored 3 goals, third game 0, 3, and then can you see now in that case, what problem are we solving if we want to predict the score for the next game? What problem are we solving if you want to predict how many goals will Real Madrid score on the next game?
Regression, that one.
That would be a regression, because in that case, it can be any value. Do you understand that? So now here we have that's the difference between classification and regression, and then we have clustering as well, which can be close to classification, but here we are dealing with bigger clusters based on similarity. And remember, the most important thing is the fact that in clustering we have unlabeled data. So we will talk more about this as we move on and talk about different algorithm type and everything. Okay. So I think that will be all for today. And tomorrow we're going to talk more about clustering and move forward. All right, guys. Any question? Any question before we can call it a day? Any question?
So can you please clarify about the big data mock exam?
All right. Okay, guys. Here is what you need to know. I don't think anyone should even fail that exam, because the summary that I gave you, I am pretty sure in the summary I gave you, I'm sure that 90, if not 95% of questions in that summary will be the question in your exam, if not all the questions. So is to tell you, if you go through the summary, there's no way you can fail it. You will realize that every question you've seen in the exam, you've seen it in the summary. That's the first thing. And the second thing is we were asked to write the mock exam before Friday because they need the vouchers to be released in a certain time, at the same time as any other courses happening in the country. They want to send a group of voucher at a time. That's the problem. So we don't want to delay that. So that's the only opportunity we have to have vouchers for the exam, which we need to apply by Friday. That's why I made a summary to make everything easy for you. So if you focus on the summary, when you're looking at those questions, study backwards. Don't study, then you do the question. No, go through the question, you look at the question, then you look at the section about those questions, then you can look at it and understand the question. And that will be easy for you. It's going to take you less time, because I understand there's people writing exams and that. So it's going to be very easy for you if you take it that way. Yeah. But what you need to know, it's very important that there will be no way when you're writing the mock exam, you will be able to click on anything on your screen, because if you click on anything, it's going to give you another attempt and then another attempt, and then it kick you out. Something else that you need to note is that the mock exam, when it comes to the mock exam, you can write it whenever. Everyone writes it in their own time, as long as you write it before Friday, 12 o'clock. So if you write your exam, you pass your exam, you can take a screenshot, send it to me with your full name, so I can record it with your full name, because for some people on the system, it's still not writing the full name. So we don't want to get it wrong when applying for the voucher. So you get a screenshot of your results, and then you send me a screenshot. Yeah. Is there any question or any clarification you need? Anyone
When you
else?
say Friday by 12, so you mean 12 p.m. or as soon as Friday starts midnight?
Yeah, 12 p.m. obviously.
Oh, okay. Just wanted to be sure.
Yeah, good. 12 p.m. because we need to do it earlier, because the system and everything is looking at the Chinese time. So we don't want to go to the afternoon to avoid that in China it's already Saturday. And then they say we've applied late. So
So sir, when I'm writing the mock, I am allowed to use the 3 attempts.
okay, here's the thing. The 3 attempts are there for you, but it's 1 attempt per day. So if you today is Tuesday, and then we have it until Friday, so you can use your attempts, but you must just know you will have 1 per day. So you don't want to get to Friday and then you're attempting, let's say you're attempting for the first time on Friday, because what I would suggest is if you have time to go through the summary is enough, and then you can maybe attempt tomorrow and see the questions, see how you can have a feel of the exam, and then on Thursday again you try. I wouldn't suggest that you, and even if you have to take on Thursday, on Friday, let's see, Thursday, Friday, because you must remember when it's counting 1 attempt per day, it's also counting the Chinese time. That's the problem. So just make sure that your last attempt or your best attempt is done before Friday 12 o'clock. That's what it means. It means it's up to you to write whenever you can, as long as one of the attempts is a pass. Yeah. Any other question? Yeah, but you will notice that when you attempt for the first time, by the time it's the second time, you realize it's the same. It's most of the question are the same question, but it's just different orders, things like that. But I'll promise you, if you take the summary that I sent you, the summary has everything. Let me just have a look at. Give me a second so I can just show you that. We have I'm just gonna log into the mega folder now. Guys, everything that I gave you on that folder, don't confuse yourself. Everything I gave you on the folder is what you need to pass this exam. It's as simple as that. I've summarized it to the level where I've made it simple, really simple for you. All right, so let me just make sure I'm sharing that. So guys, in the pin message on the WhatsApp group will have this the link to the mega folder, and this is how the folder look like. I hope you guys can see my screen, right? Can you see the cloud track competition folder? Can you guys see it?
Yes.
Okay, so in this folder, you have your big data, AI, and computing, cloud computing. So we are in big data. So we have these three files. You have, this is the full course, and then you have the summary, and then you have the link to the recording. So when you look at this summary, guys, this summary is what you need. So you basically have the definitions, and then it shows you a few important keywords definitions of different sections. So basically, you can see which section we went through and what everything does. Okay, so for example, you have here your chapter 1 that talk about the fundamentals of HDFS. We've learned what is HDFS and different keywords in HDFS. We have like name node, data node, all this. And then you go to batch processing frameworks that help you with processing the data. You have your MapReduce and your Spark. And then it tells you the keyword in MapReduce, in Spark, what to do. And then you have your stream processing for messaging, like your Fling, Kalpa, Plume. You see, so we have that. Okay, so, and then you have your databases. You have your HBase, ClickHouse, and Elasticsearch. Okay, so and then that's all with the summary. Then from here you have just a few questions based on different section. For example, you have been introducing that few questions that you need to know. So and then question with the answers there. And then most importantly is this part of the questions. There's just below, when you scroll below here, Huawei Big Data 3.5 course questions. These questions are actual questions from the exam. These questions are coming from past exams. That's why I said you may end up finding out that all these questions or 90% of these questions are in your mock exam. So you can see these ones are true or false questions, where you see false and true. These are true or false questions. Okay. You have your true or false questions, and then you have your single. Please note that your single answer question means that you have one answer. This is an example. Which of the following module in HCFS file is used to store metadata? So you look at something like this, you have your answers there, and there's only one answer here, which is different from multiple answered question. Multiple answered question, there is more than one answer to a question. So you're going to see that, which just want to scroll to multiple answers question. Yes, something like this. Something like this. You have a question, but the answer can be A, B, and C. You understand? So you have this, which of the following functional components are included in HBase architecture? You have a client, H master, and that's so H, B, and C. See, so that's it. But what I'm saying, guys, is all these questions are the question you're going to have in your mock exam. If not all of them, 90% of them. So if you go through the summary, there's no way you can fail the exam. Okay. Any question? Any question? All right, guys, if there's no question, it's fine. We can just turn on our camera, attend the screenshot, and then call it a day.